First, we'll look at long division with numbers. Let's try to find 6,175 divided by 25. So you might have done long division in school, but maybe you didn't write things down in this way. Let's get started. You first ask yourself the question, how many times does 25 go into 6? No times. So let's move on. How many times can you fit 25 into 61? Twice. So you write a 2 there. 25 times 2 is 50, which you write here. And then we subtract 50 from 61. So 1 and 6 minus 5 is 1. And then you move the 7 down. Now you ask the question, how many times does 25 go into 117? 4 times, because 4 times 25 is 100. And you write 100 here. And you do the minus stuff. It becomes 17. Let's move the 5 down. Now, how many times can you fit 25 into 175? 7 times, because 25 times 7 is 175. You do the minus thing, and of course that's 0. And since you have 0 here, the division worked out, and there is no remainder. And the conclusion is that 6,175 divided by 25 is 247. Okay, next, let's try another one. What is 141 divided by 4? Now, you could do that in your head, but let's do it systematically. So you write 4, then you write 141, and then you do this thing. So you begin by asking, how many times can you fit 4 into 14? 3. 3 times 4 is 12. We do the minus. 4 minus 2 is 2. And so that's 14 minus 12. You move the 1 down. How many times does 4 go into 21? 5 times. So you write 5 there. 5 times 4 is 20. And then you do the minus thing, and you're left with 1. This time you didn't end the procedure with a 0 down there. This means that the division does not go out. Meaning this is not an integer, a whole number. What is the conclusion? The conclusion is that 141 is 35 times 4 plus 1. So you can fit in 35 copies of 4 into 141, and once you've done that, you have 140, and then there's 1 left. Okay? So, you can reformulate this if you like, as you get 35 whole copies of 4, and then plus a quarter. So that's one way of concluding things. Alternatively, you can continue this long division. So notice that here you had nothing to move down, but if you add some zeros here after adding a decimal point, you can now move down a 0. 4 into 10 goes twice, and notice that I write a decimal place there too. 4 times 2 is 8. Minus, so you get 2, move down that. 4 goes 5 times into 20. 5 times 4 is 20, and now you do end up with a 0. And now, with this decimal point spice, you can read off the answer. And 141 divided by 4 is 35.25. a remark on long division involving numbers. That 6175 divided by 25 is equal to 247 is the same thing as saying that 6175 is 247 times 25. Moving on to long division involving polynomials now. Let's determine what x3 minus 6x squared plus 11x minus 6 all divided by x minus 3 becomes. So our remark here is that whatever that is, whatever this quotient is, that polynomial multiplied by x minus 3 should become x3 minus 6x squared plus 11x minus 6. You can just move over the x minus 3 to this side, recalling that then division becomes multiplication on the other side. But the main question here is, what is this polynomial here? We'll use long division to find it. So you write down x minus 3, the thing that you're dividing by here, and then to the right you write down the thing that you want to divide, and then you do this thing. And you kind of proceed in the same way as before. However, there is one difference. When you ask the question, how many times does this go into that, you only focus on the leading terms. So the first question is, how many times does x go into x cubed? X squared times. So you write x squared there. Now, if we take x squared times the whole thing, x minus 3, you get x cubed minus 3x squared. And then we do the minus thing. I'm not going to write out the minus sign, but it's there. So if you take that minus this, you'll get minus 3x squared. Be careful. Now let's move down the 11x. So now we've done a cycle and everything will be the same way in this next cycle. But remember that you focus on the leading terms when you do long division with polynomials. So we ask the question, how many times does x go into minus 3x squared? The answer is minus 3x times. So we write that up there. And then we take minus 3x times the whole of x minus 3. That becomes minus 3x squared plus 9x. And now we take this stuff minus that stuff, and you get 2x. We move down the minus x, focusing on the leading terms. How many times does x go into 2x? Well, twice. So we write plus 2 there. 2 times x minus 3 is 2x minus 6. We do the minus thing, we get 0. And since we get 0 down there, it means that the division went out. The conclusion is that x cubed minus 6x squared plus 11x minus 6 all divided by x minus 3 equals x squared minus 3x plus 2. And as we mentioned in the beginning, this is the same thing as saying that x3 minus 6x squared plus 11x minus 6 is equal to x squared minus 3x plus 2, all multiplied by x minus 3, of course, within brackets. Don't forget brackets. Let's quickly look at an application of long division involving polynomials. Suppose you're asked to solve the equation x3 minus 6x squared plus 11x minus 6 is equal to 0. Suppose you happen to notice one solution, for example 3. So 3 is a solution because if you plug in x is 3, you get 27 minus 54 plus 33 minus 6, which indeed is equal to 0. Anyway, suppose you spot one solution, in this case 3. Then you can proceed as follows. Since 3 is a root, the factor theorem tells you that you can divide your polynomial by x minus 3. There will be no remainder. So, before we found that x cubed minus 6x squared plus 11x minus 6 divided by x minus 3 was x squared minus 3x plus 2. Okay, so by using this factorization, you can reformulate your equation as saying that the product of x squared minus 3x plus 2 and x minus 3 should be 0. And here's the nice thing about factorization, that the product of two guys is 0 precisely when either the first guy is 0 or when the second guy is 0. Of course, this neat trick required that the right-hand side, one of the sides of your equation, was 0, because 0 is a very special and nice number. And now you're basically home. So in this way, by spotting a solution, dividing by x minus that root, you find a factorization, and then you just need to solve a quadratic equation and a linear equation, and the answer to the original question will be both the roots, the solutions to this equation, and the roots coming from solving this equation.